Hello, I am Meherchand, and in this lecture we will discuss about SymPy, one of the most important library of Python. SymPy is Python library for symbolic mathematics, and its aim to become a full-featured computer algebra system while keeping the code as simple as possible in order to be comprehensible and easily extensible. SymPy is entirely written in Python, and in this lecture we will discuss and demonstrate about how we can use SymPy for differentiation, integration, and limits. We can easily use SymPy without installation in our system. Just you need to use the URL for live SymPy. The URL is live.sympy.org, and when you will enter, SymPy live shell will open, and the entire console of live SymPy you can see here, and it will take a few seconds to open entire SymPy live shell. Okay, so all these statements which you can see here must be appeared, and only then you will be able to use this SymPy live shell. And the most important thing is that you can use this live.sympy.org in any device without installation. Even you can use in your mobile. Okay, see here, by using this sign you can clear the console, and from this place you can restart SymPy live shell, and from this you can run the statement. Okay, then after you can see there are few statements. From SymPy import, we can easily import the SymPy library in the Python. So this statement is required, and for the meaning of this statement, finish underscore printing. We are able, by using this statement, we are able to print the Unicode characters for mathematical expressions. And the next statement is used to declare the variables. Here x, y, z, t, 4 variables are declared by using symbols function, and a symbol function will be used to declare for your custom symbols. Okay, here x space y space z space d, and quote signs are used here for the symbolic variables. Similarly, you can declare the integers by using this statement, and the last statement is used to declare the calculus functions. Okay, after that you can easily see the prompt sign. This is the prompt sign. So all the statements you can easily enter at this place. Yes, so here I am choosing very simple function. F is equal to, I have sine x cube, this is sine x cube, and again when I will enter here f, this will return the symbolic expression. So here this is the syntax in Python, and this is the symbolic form. Okay, so now we can perform all the operations on this function. First, we are going to cover how we can differentiate this simple function. Okay, and to differentiate we have diff function, and f comma x. This will return first order derivative of f. So when you will enter, this is the corresponding answer of this operator. Okay, if you need higher order derivative, then we can do also diff f comma x comma x comma x. Here we are using x 3 times. It means this will return third order derivative of f function. So when you will enter, this is the corresponding answer, the corresponding returning value. Okay, the another way to find out the third order derivative, you can use this statement also. This will return the same value as you can see in the previous statement. Again, if you need fourth order derivative, then you can just change the number. So this will return fourth order derivative of the above function. You can see If there is one more expression, see here, DER is equal to, DER is just the variable to assign the value, okay, and here derivative, we are using here derivative function. Again here is f, then comma x comma 3. So when I will enter DER and enter. So the meaning of this statement we have is this one, third order derivative, and this will return the expression in symbolic form. As you can see here, third order derivative with respect to x, sine x cube. Further, if you want to simplify this expression, then what you will do? We will use here dot, then do it function. Do it function will simplify the above expression. When you will enter, this will return the simplified value of above expression. And also you can calculate any order, okay. One more example, and DER dot do it and then enter. Okay, so in this way we can easily use these functions. First is diff function. This will return the value directly, and if you need in the symbolic form, then you will use derivative. But keep in mind the syntax in Python are very sensitive. A is in uppercase. If you will use in the lowercase, then it will return error. If we have a function involving multiple variables, then we can perform all these operations also, and it's also very quite simple and interesting. See here, I have a function fun is equal to, I am choosing here very interesting function. I have is x square plus y square plus z square. So this is the function, and fun, see, I have sine x square plus y square plus z square. Now we can differentiate DER is equal to derivative. I am using here derivative function, and then fun, this is the function. I want to differentiate this expression with respect to x, with respect to y, with respect to z. So this is the third order partial derivative with respect to x, y and z. DER, this will return in the symbolic form. The meaning of the above statement we have is third order partial derivative with respect to x, with respect to y, with respect to z. Further, if you want to simplify, we can use here do it function. DER dot do it, then enter. Sorry, the statement is incorrect. DER do it function, okay, and we have third order derivative at this place. Also you can use a direct function. We can use here diff function also, and diff function will return direct answer, okay. If function will return the direct answer. You can see both the values are same. Also if you need uh, partial derivative of the function with respect to x 2 times, with respect to y you need third order, and with respect to z you need again third order. So when you will enter, see the expression and you can compare this statement and this symbolic form. So the total derivative is of 8. This is the 8th order partial derivative. With respect to x we have 2 times, with respect to y we have third order, and with respect to z we have again third order. So this is the symbolic form of the above expression. If you want to simplify this one, then you can easily use do it function. Okay, do it function is used just for simplification everywhere. You can use. So you can see here is very long answer for the above expression, and it will return the answer very frequently. Take very less time in simplification. Okay, now we want to integrate. For the integrate, we have this function integrate, and I have x square. I want to integrate with respect to x. Okay, then I will enter. So the integration of x square we have is x cube upon. If I am using the same like in this way integral. Okay, we have the function integral for the symbolic form to convert the statement in symbolic form integral, and see I have x square. Okay, with respect to x, and when I will enter and int, this will convert the statement in symbolic form integral. Okay, it will take some time. It is taking some time. If the answer is not returning, we will refresh it. Refresh the statement, or you can open new link. Okay, so yes, it is opening now. Yes, now we can enter the statement. So see the entire window. When will open, after that we can enter the statement. So here we are using here int is equal to integral, then I have x square and comma x. So integral statement is function is okay, integral, then enter. So the statement has been entered and we found that it is correct, then enter again int c. So this is the symbolic form of the above statement. So when you will print the value, the expression will return at this place. And further, as we were doing in the previously for a derivative, we can use here do it function also for the simplification. Do it and use parentheses, then enter. So this will return the value after simplification of the above expression. If we have int is equal to integral, then I have exponential function which is minus x square minus y square, then this is the definite integral. The limit of x we have is minus infinity. Double O in lowercase is used for infinity. Okay, minus infinity to infinity. This is the limit of x, and then we have the limit of y. That is also minus infinity to infinity. Note this point how I am entering the limit for this expression. Okay, and then enter. So this is the statement which I enter at this place, and when I will print this expression, so this is the actual expression in the symbolic form. lower limit of x and y we have minus infinity and upper is infinity. E raised to power minus x square minus y square dx dy. This is the double integration. Okay. And if you want to simplify, then you will use here do it function. Okay. You will use here do it function. So it will return the answer after simplification, which is pi. Okay. Similarly, we can do triple integration. Okay. For the triple integration, also I would like to show you just 1 minute. You can use here integrate function, and integrate function will return the value directly. Integrate. Okay. Integrate function will return the value of this statement directly. Sorry, statement is incorrect. So you can see here is the name error, and integrate is not defined. So what is the problem? Problem is that the syntax is incorrect. Here is R. Now I will enter, and you can see the same answer. Okay. Within the one statement we have the returning value, which is pi. Also, pi is inbuilt function in Python. Pi is the syntax for the same. If you have a triple integration, how we can do triple integration? This is also very interesting part for the triple integration. I have int is equal to integral. Okay, I have integral function. Then I am choosing here function is x product y product z. This is the function. Then I have limit of z. Okay, limit of z. I am taking here the limit of z, and note this point very carefully because this is very sensitive part. Okay. And you need to understand the syntax, how we can use for triple integration when the limits are in the form of variable, when the limits are not constant. In the previous example, the limits was constant, but here the limits are not constant. Okay, so note this point very carefully. I have the limit of z is 0 to square root of 1 minus x square minus y square. Okay. Then I have limit of y, that is from 0 to s square root sqrt. Okay. And it is 1 minus x square. Then I have limit of x 0 to 1. Okay, so this is the expression when you will enter. See the statement very carefully. Okay, again enter. So this is the expression in the symbolic form for the above statement. Okay. So if you have the expression in this form, then the above is the syntax. And when the limits are not constant, you have to use in this way. Okay. Otherwise, there will be error and it will not return the value. So now, if you want to simplify, then you will use int dot do it function. Okay, int dot do it function, and when I will enter, this is the corresponding answer. So in this way, we can use int and integral function for single integration, for double, for triple, okay, for definite and indefinite integrations. Now we have last topic, which is limit. How we can calculate limit by using this library. So you can see limit of sine x. This is the syntax. Okay, I have sine x upon x, then x approaches to 0. I have, this is the very simple example I am taking here just for the demonstration. And first we have the limit, then we have first we have the limit function, which is the syntax in the Python. Then after we have sine x upon x, this is the function, and at the end we have the limit x equals to 0. This is the main statement, and when I will enter, this will return is equal to 1. And if you want to convert in symbolic form, this is limit sine x upon x, okay, then x approaches to 0. LIM, the information stored in LIM. When I will enter, so this is the expression in symbolic form. So this is the limit x approaches to 0. Okay, this is the limit x approaches to 0. This is the function sine x upon x, and this is the limit function for limit. Further, if you want to simplify, then we have do it function, and we are using here enter, and the value of this expression is 1. Sometimes we have left limit and right limit. We can do the same also. See, I have left limit is equal to limit limit. I have 1 upon x, then x approaches to 0, and again I need left limit. Left limit, for left limit we are using here minus. So this is the syntax for the left limit. Okay, so when you will enter left lim, see, this is the symbolic form of the above expression. This is the left limit, and if you want to simplify, then use do it function as we do for derivative and integration. So when I will enter, this will return minus infinity. If I want to calculate the right limit, then I have to use here plus sign, okay, and here is right. Okay, so the information will be stored in the left hand side. When I will enter and right, sorry, or right LIM limit, yes, so limit x approaches to 0 from right side 1 upon x. If you want to calculate, then use do it function, and this will simplify the above expression, which is infinity. So previously the left limit was minus infinity and right limit you can see is plus infinity. So both are not equal. Okay, so in this way we can easily calculate the limit, left limit, right limit also. In the present session we discuss about how we can do differentiate, partial derivative, integration, definite integration, double integration and triple integration. and at the end we discuss about limit, left limit, right limit. I hope the content which I present here are very helpful, and all these will help you to understand the syntax, how we can use this SymPy library in Python. So SymPy library we can open in live mode by using the live.sympy.org URL. Many things are there. So in the coming session we will do some more advanced topic, and all these will help you. Thank you very much to see this lecture till the end, and if you like this video, you must share this video with your colleagues, with your student. Thank you very much.